all for coming today to this joint branch meeting. I think it's fantastic that the New Jersey beekeepers, that we can come together as clubs to have a great, ladies and gentlemen, the one and only John Gott.
Right now, I'd like to introduce Peter Borst. Peter's worked in the beekeeping industry since his first job working in upstate New York in 1974. In the late 70s, he helped run a beekeeping supply store in the San Diego area, and he helped beekeepers of all levels there. Of course, he got exposed to a lot of different problems and issues that bees have, helped the beekeepers through those concerns. Among other things, Peters has been the senior apiarist at Cornell's Dice Laboratory for honeybee research for 7 years. He was an apiary inspector in the state of New York between 2006 and 2008. And he's still working at the Cornell doing biomedical research. And he's also president of the Finger Lakes Bee Club. Peter is a regular contributor to American Bee Journal. Many of us have seen his articles and enjoyed them. He writes on topics as diverse as beekeeping techniques, the composition and value of pollen bees, and the history of beekeeping and bee breeding. Tonight, Peter will share some insights about the history of the hive and what's really going on in those dark hives. What's really going on 24/7 in those dark hives. With that, Peter.
Is this picking up okay? Thank you very much. Does everyone hear me okay?
Yes.
Too loud? Seems loud to me. So the topic tonight that I've decided to talk about is, seems like it's cutting in and out. No, it's fine. Is, what is going on in the dark of the hive? So that's why I'm presenting a slide. This is basically, if you look inside the hive, the way the bees see it, it's completely dark. All of the activity that takes place inside the hive is done in the dark. They have no lights to guide them. And so this would be, to give an example, this would be like having 50,000 people in an auditorium with the lights out, and everybody knows exactly what to do. All the tasks are being carried out, and no one is bumping into each other. And so that's the example I give. But looking into the hives early on, people began to imagine what was going on inside the hive. One of the first things that they noticed was there's this large bee and all the other bees surrounding that large bee, and they began to call the large bee the king. And it turns out that pretty much whatever society looked into the beehive and saw their ruler, their style of ruler was the one that was commandeering the colony. And the colony was doing the bidding of either the pharaoh or the king, or the main ruler was always identified as a male because all of these societies had males as their rulers. And so, throughout the Egyptian artwork, you see this motif repeated again and again. So they used this hieroglyphic, this large bee with a long, slender body. That was the symbol for not only the king bee, but also the pharaoh, the king of their society. And the concept was that, a powerful ruler like that could commandeer tens of thousands of individuals to build whatever it was that needed to be built. Here's another example. This is in Crete. Throughout the Mediterranean region, Crete and Greece, and later on in the Roman times, the large bee was always regarded as a male, and it was always thought that the male leader, was commandeering all of these workers and getting the job done. And it wasn't until 16, 1700s that people began to really study the bees themselves. And lo and behold, they found out that this large bee that was supposed to be the king was filled with eggs. And it was actually a female, and she was laying eggs. And all the, so the concept became a feminine monarchy, but still we're regarding the leader as a ruler. So we're still using the metaphor of monarch. Now she becomes the queen instead of the king. But the concept is still that she is commandeering all of these workers to do her work for her. And this is an example of the type of manuscripts that were being produced at that time. They're beautiful to look at, but they didn't hold a lot of information. As a matter of fact, Aristotle was one of the first persons to really write large manuscripts about beekeeping life, and he basically would pick up what everyone else said and just repeat it. Most of the authors of that time, their technique was to read everything they could and then just repeat it. In one of his books, he mentioned that some of the beekeepers have been mentioning that the big bee might actually be a female, but they knew better that it was a male bee because that's what all the other texts would say. So it wasn't until we began to build hives where you could actually open up the hives, look down in there, and study the colony's activities from week to week, month to month, and year. And so Francois Aubert, French beekeeper, was one of the first persons to really study the biology of the bee. And he had, in order to do this, he had built himself a frame hive. This was 100 years or so before Langstroth developed his frame hive. And as you can see, the frames are hinged together like pages in a book. And so it's a very, very difficult hive to use. So their skill level is very high for them to be able to use such a complicated, difficult hive. But they were able to make incredible advances in understanding what was going on inside of the bees' colonies. And at this time they realized that the workers were also females, and that the queen, would mate with the male bees, but this was not taking place in the hive. So then the next person I'd like to talk about is Charles Darwin. And he was one of the first persons to identify the fertilization of flowers. See, up until this 1800s, 1700s, 1800s, no one actually knew that bees were pollinating flowers. This was a complete mystery. In fact, a lot of the fruit growers disliked beekeepers and tried to keep beekeepers and their hives away from the orchards because they had the idea that the honeybees and other bees were actually eating the fruit. And so they really had an animosity towards beekeepers and fruit growers, and until they realized that actually the bees were fertilizing flowers. And some people actually thought that bees were stealing the pollen and preventing the fruit from growing. So, but one of the most interesting things that Darwin discovered was that through the cross-fertilization of flowers, he began to get hybrids. And one of the things that bothered him the most about studying evolution was that studying the fossil record, things pretty much stayed the same for a very, very long time. And then there was what he called an explosion, the Cretaceous explosion, where all of a sudden you had many, many, many new species of plants and insects all at the same time. And he said it pretty much made his whole theory suspect, because how could this happen all of a sudden? He viewed evolution as a very long, gradual process. And it was at first, as we know now, 3 or 4 billion years passed, and life evolved very, very, very slowly. And then all of a sudden there was this explosion, and he theorized that the insects, together with the flowers, began moving pollen from one flower to the other, and created lots and lots of new combinations and ultimately new species. So we can thank Darwin. Another thing that he noticed was that there was this very, very close relationship between the bees and actually all pollinating insects and the flowers. Here is an example of a flower that's producing a form that actually looks like a bee. And when you see this, you wonder, why would that flower present like this? What actually happens is that male bees will come and try to mate with this flower, and in the process, they're going to pass the pollen from one flower to another. So these flowers over millions of years have devised these tricks, these techniques to attract insects to them in order to get the work of pollination done. So it's almost like a bait and switch operation. There's another picture of the same. I mean, when you look at this, you think that's just amazing that looks so much like a bee. And we're going to talk more about flowers later in the talk, but in the other ways that they attract insect pollinators. Okay, so this is one of my favorite authors. This was actually the first book that I ever read about bees and beekeeping. The Life of the Bee, written about 100 years ago. And this particular author was a French playwright, so he took the story, what was going on inside the hive, what they knew at that point, which was quite a bit since we'd already passed through the whole Langstroth revolution. Now we had frame hives. People thought they were pretty smart about what was going on inside the hive. And he wrote this whole exciting story about what was going on inside the hive. The drama and the excitement. Here we have the virgin queens fighting to the death, and it makes a really riveting, exciting story. And so that's where my fascination for the whole beekeeping really started to take off. That was in about 1974, like was mentioned. And I thought to myself, well, at the time I was casting about for an occupation, and I didn't really know what I wanted to do with myself. I thought, well, something. Not quite. We'll get to you, Morton. Excuse me. I was casting about for an occupation, and I thought something that is this interesting is something that's going to be able to hold my attention for many, many years, and as you can see, it has done. So we can go to Morton now. So Lenny Morton Wheeler, he's sort of peripheral to this whole story, in as much as that he studied ants. But I should just say at this point, ants, wasps, bees, they all belong to the same family, the Hymenoptera. What they have in common is that they're insects. They go through the traditional, the standard metamorphosis: egg, a larva, pupa, adult, and many of them form societies. Now, all ants are social. All ants form societies. Whether it be a small nest or a giant nest, they always have the queen or several queens and the workers. Wasps and bees, on the other hand, most of the wasps, most of the bees are not social. They live a solitary life where the female lays the eggs. She leaves, she never sees her offspring, she doesn't take care of her offspring. She leaves them and they form the next generation. And they're the ones that do the same thing the year after that. But the reason why I bring in Lenny Morton Wheeler is because he was the first one to really understand that a colony of ants or a colony of bees, for example, is an organism. And he was the first person to use the term superorganism, which envisions the colony as having basically a life of its own. It's not the queen, it's not the workers, it's a whole unit. So this is a beautiful illustration of what goes on underground. And the reason why I'm bringing these in is because I think it's very useful to look at the other social insects to get a sense of what's going on inside the hive. Because there's a lot that's the same, and there's a lot that's completely different. What is the same is that they're caring for their young. The queen lays the eggs. Thousands and thousands of eggs per day, and they're cared for by the workers, and each of these workers has a particular task that they know that this is their task. They perform that task and don't try to perform some other task. So this is a picture of the different, what were called, at that time were called castes. So you have the queen and the various different castes of workers, and then, of course, the males. And these castes not only perform different tasks, but in the case of the ants, they have quite different size. There's soldier ants that go out in battle on the colonies, and there's the nurse ants that take care of the brood, the same as the honeybees do. Next slide. This one is, you have to kind of stare at it a little bit. what you have on the ceiling of this little anteroom, this little cave, are actual ants that are using their own bodies as storage pots for honey that the other ants have gathered. So they're actually using their own bodies as receptacles and storing the honey. They're unable to build a comb the way our honeybees do. And again, this is another caste. This is the storage ant caste. This is sort of my segue into what William Morton was getting at, was that he was trying to make the case that these ants are raised for specific tasks, and none of them has any ability to go on beyond that task, and beyond that task. So Morton Wheeler was friends with the Huxley brothers. We have Aldous Huxley and Julian Huxley. Julian Huxley was an entomologist. He studied ants, and Aldous Huxley, of course, was an author that wrote the book *The Brave New World*. And *The Brave New World* describes a society that was based on Wheeler's discoveries and Huxley's ideas. This is an illustration that went along with *The Brave New World*. And the idea in *The Brave New World* was that humans could do the same thing, where they would raise different castes that were designed to do different purposes. And the way that they would do this would be deprive the babies at a very early age of the proper nutrition, so that they would grow up to be stunted individuals. Next slide. I've already spoken about Huxley. Next slide. This is a scene from the BBC production of *The Brave New World* that came out in the 80s. And this one shows the subcaste. These individuals, they're humans, but they were raised to be stunted and be able to take orders. So the concept here is that these individuals are not going to give any kind of resistance to the society, because they're basically unaware of their position in the society. And the reason why I bring this up is because they began to believe that the same type of situation was found in these ant colonies, and by extension in the honeybee colony. So, next slide. And of course, I just throw this in because this same theme seems to recur in science fiction. The idea that human beings can be used as material for some higher purpose. In the case of the Matrix, human beings were being used to produce electricity as batteries. So we'll get back to the whole idea of the stunting of the workers in order to produce a whole race of bees that are compliant and do the bidding of the queen. Colin Butler wrote this book. He was an Englishman and wrote this book about the world of honeybee. He was the first person to discover that the queen produces a substance, which he naturally named queen substance. I'm not going to read this. The queen substance was thought by Butler to be the substance that caused all the bees to basically supplicate to the queen. They would maintain sort of a control over the colony by producing this sort of hypnotic effect on the bees. And he was so convinced that this was the ticket to controlling the colony that he patented this chemical and envisioned selling it to beekeepers so that they could put this in their colonies, and it would keep the colonies happy, prevent them from swarming, and doing all sorts of miraculous things. Next slide. Well, the way this substance is transmitted from colony to colony, and this ties back into what Morton Wheeler was saying, they have this process which is called prophylaxis, where one individual, whether it's an ant or a honeybee, passes her food to another member of the society. She passes her food, and the food is swapped constantly throughout the colony, so that all the bees in the honeybee colony are sharing the food supply, and it mixed into this food supply, which everyone is sharing, is this queen substance. So everyone is getting a taste of not only all the honey and pollen that's coming into the hive, but also this queen substance. And this is how they're aware that the queen is there. So if the queen is removed, as you know, the queen is removed, within a day, bees are aware of the fact that there's no queen among them. And Butler was the first one to theorize that was being passed through the food supply. Next. He also pointed out that, there was this substance, which at one time was thought to be an odor, was permeating the colony, and this helped them to organize the swarm. When the swarm was on a tree like this, you've noticed that if a swarm hits a branch on a tree like that, the bees are able to find it, and it appears that they're finding it by following some sort of an odor. And then after the swarm breaks cluster and goes somewhere else, you'll always see still a handful of bees clinging to that one spot, as if there's some kind of an odor that's still there, that's from that queen. Next. So this is a picture that I took, which pretty well exemplifies the attraction that the queen has, to the workers. They all seem to want to be by her, and they're all touching her with the antenna. We'll talk a little bit more about the antenna. Touching her with the antenna, licking her. Next slide. It shows the trophallaxis, where they're swapping the nectar. The worker bee on the right is passing the nectar and pollen and probably royal jelly to this queen, and continuing this process of food being passed from one individual to another, so that they're constantly aware of the fact that the queen is among them, and that keeps them contented. So this was the theory, was that if this substance was in the hive would maintain its functionality, and if the queen was removed, everything sort of breaks down and chaos takes over. And Colin Butler thought, well, next slide. Colin Butler thought that if you could manufacture this product and distribute it, that you could have more control and more uniformity among the colonies. This is a picture actually of bumblebees. Bumblebees have a very, very similar sort of arrangement. Excuse me. But there was some very, very important differences. So with a bumblebee, queen emerges in the spring, having overwintered in the ground somewhere, and is completely alone. She goes out, begins to collect honey and pollen, and starts to make a little nest for herself. The first individuals that she raises are stunted individuals, which ties in with what we were talking about before, the Brave New World, the society with the stunted individuals. These little tiny bumblebees appear to have no real desire to do anything except for work for this queen. And as the colony enlarges, she begins to raise larger bees, and they begin to be more like her, up to the point where actually they're fully mature, fully functional females and males. Those go off to mate, and that produces the next generation. This queen that's running this colony, she'll die. She doesn't live more than 1 year. So this is how the bumblebees solve the problem, carrying the colony from 1 year to the next. They don't try to winter over the whole bunch of them. They try to raise enough bees to produce mature individuals, and those mature queens are the only ones that survive to the next year. So, chopped off on the left there, it smells like queens since the Cretaceous. So this is tying us back into the whole history, the whole evolution of insects and pollination. Evidently, these chemicals that are present, that we were identified as the queen substance, evidently these chemicals have been around for a very long time. Next slide. This is a breakdown. I'm sorry, it's cut off on the left here. What it says up here on the left is termites. Termites are also, as you know, are also social organisms. They're not hymenoptera. They're actually a form of cockroach. But they also have a system where they have a queen, which is actually quite large. Looks like a loaf of bread compared to the other termites, and is producing a very similar type of substance. These are long-chain hydrocarbons. The next one that's chopped off is wasps. And so you have wasp vespula, the yellow jacket up there with a very long-chain hydrocarbon, looks very similar to the bumblebee hydrocarbons, and then down here among the ants. So this is tying all of these different species together. They all seem to produce these substances which, at the very least, they signal to the colony that the queen is present. Now, we're also going to breach the idea that they may not just be signaling, but they may actually be controlling these insects so that they are doing the work that they're supposed to do. So next slide. This is the queen substance. This is chopped off again, but this is the main component that Butler discovered, and he was convinced, of course, that this was the queen substance. It's produced by the mandibular glands. These are glands in the head of the queen. The worker bees also have mandibular glands and produce secretions as well. But he discovered that it was not only a controlling substance, but it was also the very substance that was attracting drones to the queens at the time at which they're mating. And when you look at the other insects that we described, not only those, but other non-social insects, they also produce these types of substances, which evidently have a very strong odor to them. And I should point out at this point, these insects have a fabulous sense of smell that far exceeds anything that we have, although we can be trained to be able to smell and taste things much more than we already do. Part of the reason why they're so sensitive to smells is because they spend a lot of time in the dark. They don't. If you cover your eyes and ears, you will find that your other senses begin to become accentuated. For example, a blind person may be much more sensitive to touch and smell and sound. So if you had none of those other senses, if all you had was sense of smell and taste, that would be a much more well-developed sense. Next. So this is just an example of Butler's product that he had such high hopes for. And in fact, this idea was picked up by researchers in British Columbia during the 60s and 70s. In British Columbia, Mark Winston and some of these other researchers had the same idea that Butler had, was that if they could patent this and package it up, they could control bee colonies. They wanted to sell to packaged bee producers. They could put it in their packages and keep the bees calm. And they also had another product called Fruit Boost, which was supposed to be sprayed all over orchards and would attract bees. And to make a story short, none of this worked. Next. So I'd like to just fast forward to the present time. I have to just tell you this, that during the 30s, 40s, and 50s, almost 99.9% of the bee researchers were males, and it was a male-dominated society. I work at Cornell, and Cornell was a male-dominated society. Women were just really not encouraged to take part in agriculture, research, scientific research, and this is completely changed, especially in the field of honeybee biology. I haven't met Cynthia, but she's done some very interesting work on bringing us up to speed on what these chemicals are actually doing. Next. So this is chopped off again. The projector's giving us a hard time tonight. So this is where we tie in the solitary bee. I mentioned the solitary bees earlier. Solitary bee, places her eggs in a hole in the wall or in the ground, and the young are on their own. They grow up without any care. They are on their own from day one. This process has been modified in the honeybees society to where the larva has various pathways that this larva can go in her life. This, as you know, a honeybee egg has the potential to be either a queen or a worker, and depending upon how it's fed, chemicals that are added to its food, and later in its life, there's more pathways that can go. It becomes specialized as a forager, nectar, pollen, water gathering, propolis. They have all these different tasks, and somehow they are able to allocate tasks so that you have enough bees doing this, enough bees doing that. Obviously, if everybody gathered water, no one gathered nectar, we wouldn't get any honey out of the deal. Next slide. So this is an illustration from Cynthia's papers. Up at the top we have the queen substance, and this is bridging the idea that we don't really know whether whether they're picking up a signal from the queen, and that tells them, what they're supposed to be doing. It organizes the hive, or if it's controlling the substance, where they're actually held in place by this chemical, basically a chemical handcuffs. As you've heard of psychiatric wards where they give the patients chemicals so that they behave themselves, etc. So there's the concept that either these chemicals are controlling the insects so that they can only do what they're supposed to do, or the chemicals are providing a signal which tells the workers state of the queen, state of the colony, and then they just do what they're supposed to do as they see it. Next slide. So underlying this process that I'm trying to describe here, task allocation, is the fact that both queen and the workers have ovaries. So it used to be said that the queen was a perfect female bee, and the worker bee was somehow just unfinished. But the fact of the matter is, as beekeepers, we all know, the queen has certain things that only she can do, and the workers have things that only they can do. They build the wax, they collect the honey and the pollen, they have the wax glands, so they can produce wax. She has none of these things. So basically what you're seeing is two sides of the same coin, which takes us back to the idea of the colony being a superorganism. It's not about the queen, it's not about bees, it's about them working together to get the job done. But this here is the queen ovary. The queen is capable of laying thousands of eggs per day. These eggs are being produced constantly. She lays her own body weight in eggs every single day. So they have to be produced constantly. Essentially what she has in her ovaries are stem cells, and they can produce eggs on demand, as opposed to mammals are basically born with all the eggs that they're ever going to have. The worker bees, on the other hand, actually have ovaries. These ovaries can produce eggs, as we all know from the problem of laying workers. When the queen is gone, these workers will actually begin to lay eggs. These eggs can never be fertilized because they don't have the equipment to get fertilized. They don't go out and try to get mated or any of that. They don't have that instinct. But what they do have is the instinct to take care of eggs. Whether they're their eggs, her eggs, they have the instinct to nurse. And in my opinion, I suppose the opinion of some of the other researchers, is this is the primary function of the ovaries in the worker bee, is to produce an instinct whereby she takes care of the young. There's no concept, these are my eggs, her eggs, they're all working together and taking care of these eggs. And so I think that's the reason why they have ovaries. These ovaries not only produce eggs, but they also have multiple other functions in regulating the instincts and behavior of those worker bees. Next. So again, this is a close-up. This is actually two pictures of worker ovaries. This is a normal worker, well, I should say normal. The most common worker is a worker that's not laying eggs. Now it turns out that in a colony of bees, there are workers that have enlarged ovaries. And we're not exactly sure why that is, but instead of saying either, the workers don't have ovaries, or the workers have ovaries that are developed if the queen dies, the truth of the matter is we have a whole spectrum of workers with undeveloped ovaries, workers with developed ovaries. These workers with developed ovaries are laying eggs all the time, and the other bees are going around going, hey, wait a minute, these are not the right eggs, and they're eating them. So laying workers are not strictly speaking, a symptom of a queenless hive. Laying workers are present in all hives at all times. Not very many, there may be a half a dozen of these. And like I said, the other week, workers are going around saying, wait a minute, these are the wrong types of eggs, because they can tell right away that they're laying worker eggs because they're not fertilized. In other words, if there's an egg in a worker cell, it better be a fertilized egg, female egg, or the bees are going to remove it. Next slide. So, excuse me. What it boils down to is that we're not going to answer the question tonight whether the queen is controlling the other bees through some kind of a drugging chemical, or whether the bees are picking up on the signal. It's basically, there's no way of proving it one way or the other, because we don't know what's going on inside of their minds. All we can do is experiment and try to see what kind of results we get. But speaking from the point of view of a beekeeper, it seems fairly clear to me that the queen has an effect on the worker bees that is not explained by some of these hypotheses. If the signal was directly related to whether that queen was what we call a good queen, in other words, a queen that can produce eggs, that's vigorous, etc. If the queen was signaling that she was a good queen, then as she became older, the bees would pick up on that signal. This queen is getting old, we need to raise a new queen. Now this happens often enough. It happens often enough that if you look in the textbooks, you'll see they'll say that if the queen begins to get old, bees will replace her. But as a beekeeper, we all know that this does not happen like clockwork. Very frequently, we'll see a very old queen no longer able to produce eggs, and yet the bees are not replacing her. Why are they not replacing her? So this is one of the things that beekeepers see that the researchers don't see, and it basically, to me, it shoots a hole right in their theory. These queens are able to maintain their influence over all of these bees long past their usefulness. And by the same token, you and I have all seen where you've got a brand new queen, maybe about package bees, or maybe about a queen in the mail, put her in there, and 3 or 4 weeks, bees are starting to raise supersede themselves. For some reason, that queen, even though she's brand new, and apparently to us is perfectly fine, and also would cost me $30, they're not happy with this queen. They're starting to make preparations to replace her. So somehow these two factors are decoupled. In other words, the queen can control the bees up to a point. The bees can make decisions about the queen up to a point. Next slide. So I'd like to go in a little bit more deeply. We've gone pretty deeply, but not as deeply as I'd like to, into the chemicals. Now, Butler was pretty well convinced that there was one chemical. Called it queen substance, queen mandibular pheromone. By now, actually by about 1980, 1990, it was discovered that the queen produces a variety of chemicals. And probably each one of these chemicals has a different purpose. And it appears that the queen mandibular substance that is basically a long chain hydrocarbon, it appears that may just be the medium, the substance in which she distributes all these other chemicals. In other words, bees are very attracted to this chemical. They lick it off her, they pass it all around the colony through this prophylaxis where they swap their food supply, and in the process, they're passing on all these other pheromones. Next. So again, here we have a nice close-up picture of the bees licking the body of the queen. And a lot of experiments have been done with these different chemicals. And they found that each one of these chemicals is very attractive to bees, but you have to have all of the chemicals in the right proportion for it to have even close representation of what a live queen will do. In other words, you can suppress queen rearing in a colony by putting some of these chemicals in, or all of these chemicals, but ultimately, the only thing that the bees recognize as a queen is a live queen. And probably one that is unharmed. For example, if the queen is missing a leg or is damaged in some way, the bees perceive this and will attempt to raise a new queen. Next. So this is an illustration that came from a long chapter written by the two ladies I just showed you 2 slides ago. They have really gone all the way into it to describe all the different chemicals that are used. And there's a variety of chemicals, not just queen substance, but a variety of chemicals that are used to regulate all sorts of functions in the hive. And this is just an example of it. Causing the swarm to cluster, the mating, we talked about the mating. The queen can regulate the production of queen cells. In other words, they're going to only build queen cells, when the colony perceives a need for them. The queen also tags the eggs so that the individual nurse bees realize that that egg was laid by that queen and not by one of the workers. And also we believe that some of these other functions like comb building, etc., are regulated by these pheromones. Next. So where are these chemicals coming from? We talked about the mandibular gland, queen mandibular pheromone. There's a lot of glands in the head of the queen. This is a very important gland here. A lot of people don't realize this, but everywhere the queen walks, she leaves a footprint, a chemical footprint. And it was discovered. I don't know if you've ever heard of the technique of banking queens. This is where people will take large numbers of queens in cages, put them in a for safekeeping. The idea was that you could buy 50 queens and you could put them in a bank. Then anytime you needed a queen, you just went to your bank and you took your queens. What they found out was these queens in the cages, they present to the other bees by placing their feet on the screen, and the other bees would lick the feet. That's the only part that they can contact. And they found out through the licking, constant licking of the feet, that they would actually chew the glands down on their feet. So the queens that would bank for long periods of time actually are damaged by that process. And so the answer is don't bank queens, because it's harmful to the queen. You can do it for a week or two, but over a period of time, they're going to damage the queen by licking and chewing on their feet. Then you have these other glands we'll get into in a minute. Next slide. So this is a worker bee, and it shows you that they also have most of the same glands. So the worker bee and the queen bee are very, very similar in a lot of ways. Because obviously they're coming from the same egg. They've got the same genes as the queen bee, and can produce a lot of the same substances. So, next. The long and short of it is that the queen produces a variety of substances, and the worker bees also produce a variety of substances. And all of these chemicals are exuded in the hive in the dark, as we said at the very beginning. All this is taking place in the dark, and evidently is regulating the hive in some way. Now, when people began studying this, they thought, well, this is an example of communication, insect-animal communication. And there's a lot of scientists that just don't want to use the term communication or language with anybody except for human beings and maybe a few select birds that are able to communicate with each other. They would rather call it a regulatory system rather than communication. So it's a valid point, because is the queen actually trying to transmit a message? Is she trying to communicate with her worker bees? Are they trying to communicate with her? Or is it just, they're all just going through the motions based on signals that they're picking up from each other that are telling them whether they're doing the right thing or not? So anyway, beyond that, what we have here is what is the organ that is sensing these smells, these signals? The antenna. Obviously, they don't have a nose, they don't have ears. Their tongue doesn't seem to have any particular sensitivity to taste. It's more like a big straw which they use to, imbibe nectar and water. Their actual organ for sensing not only smell, but taste and touch is the antenna. I've got some pictures here, next please, of the antenna. We're going to look at, and this is the tip of the antenna. You can see it has a very large number of hairs, which means it's very, very sensitive to touch. And the next slide, you can begin to see the sensory organs. These are the organs that are picking up the odors. So when a bee touches another bee or a bee touches a flower, she's picking up smell, taste, feel. All of these senses are being passed through the antenna. I think there's one more. Is there one more? Yeah, there's even closer. These are amazing pictures, by the way. This book is called, I think it's called Bee, and it's a whole book of electron microscope pictures like this. I just picked a few because it seemed to tie in with the talk, but she shows the eye. The eye of the honeybee is amazing. It covers with hairs. And when they're out gathering pollen, for example, the whole body is covered with pollen. And what they do is they comb themselves and brush the pollen down into what they call the basket. Next. Oh, yes. Yeah, okay, so we're going to move on to the other types of odors, the other types of chemicals that are produced by the bees. This is, you've seen this before, where the bee has got her head down and her butt up, and she's producing an odor with the gland. There's a gland on the end of the bee there, and she fans her wings to produce, so that this odor will transmit. And this is an orientation odor. Next. This is a close-up. It's called the Nasonov gland. It's a close-up of the Nasonov gland. And these are the chemicals, the main chemicals that are in this, what they call orientation odor. You probably have seen Swarmler. They sell this little vial of stuff called the Swarmler. It's mostly lemongrass oil, which is the strongest scent. That's geraniol. The strongest scent is geraniol, and it's sold as a product that you can put in a bait hive, and bees will smell it, and they'll orient to that bait hive, and then move the whole swarm in there. That works sometimes, I guess. Have you guys put out bait hives? I put out bait hives myself, and it seems like if you put some of that lemongrass oil in there, it's much more attractive. Bees find it more quickly, and as a matter of fact, I heard just recently, this woman said her plate glass door, like patio door, one day it was just covered with honeybees. She could not figure out why the entire glass door was covered with honeybees. And then she was talking about with somebody else. She goes, well, what was in that window cleaner that you used that had lemongrass oil? And it turned out there was lemongrass oil in the window cleaner. And bees came from all around there because they were so attracted by that smell. I want you to just kind of try to remember these was it 5? Geraniol, nerol, farnesol, citral. In the next slide. This is, you've seen this kind of thing before, where they go on and on about this wine and all the blackberry and the black currants and the licorice and the cracked pepper and green pepper and hints of vanilla and all that stuff. And I don't know about you, but when I read that kind of stuff, I go, this person is just completely, out to lunch. You can't pick these flavors up in this wine. It just tastes like wine. But the truth of the matter is, in the next slide, truth of the matter is, sorry, this is cut off. This was taken from a website where they're describing not only the flavors and smells that you can get from wine, but what are the chemicals that are producing these flavors and smells. And they're the same chemicals we just talked about: geraniol, nerol, farnesol, citronellol, and this is linalo, linalool. These are chemicals that are found in that Nasonov scent. So these chemicals are real. These chemicals have these flavors and these odors. These chemicals are found not only in wine, but in all fruits. In the next slide, they're found this is chopped up. This one's geraniol. These chemicals are found in flowers. These are the same chemicals, they're the same odors that are produced by the honeybee as an orientation odor. They're produced by these flowers, presumably to attract bees, because bees recognize these odors. These are odors that are in their lifestyle. They're odors that they recognize. Next slide. This one is nerol. This is an orange blossom. And most of these flowers have a combination of these chemicals. These are just examples of flowers that have these same chemicals that we described. Next slide. This one's farnesol. This is a basswood tree, which I don't know if you've ever been underneath a basswood tree when it's in bloom, but it just smells like heaven. And it's just a very complex, rich, beautiful fragrance that basswood produces. And obviously, what it's doing there is to try to attract bees to pollinate. The bees don't know they're pollinating. The plant doesn't know it either. But over courses of millions of years, this give and take of evolution has caused bees to produce these odors which they recognize, plants to produce the same odors which the bees recognize. This gets them pollinated, which means that these are the plants that are most likely to survive. Plants that is producing no odors, has pollen that's not attractive. That plant is not going to live very long. It's not going to propagate, and be around millions of years later. Next slide. Next. Citronellol, I'm sorry, this is chopped off at the bottom. You can see the chemical formula for all your chemists. This is a rose. That was a wild rose, which is when I moved up to upstate New York in 1991. I was in May, and in June the wild roses, which everyone loves to hate, it's multiflora rose. Everybody's trying to chop it down and get it out of their yard. I thought to myself, this is a country where roses just grow wild and it smells great. I think I'll stay. So it has a beautiful smell, despite, it's on everybody's invasive species list. Next. And this is lavender, and the chemical, which is chopped off at the bottom here, is lineolol. And it's a very, very important chemical in the attraction of a variety of insects. Not only bees, but also moths and butterflies produce these chemicals as well as a mate attraction. And of course, they're out flying in the middle of the night, your large moths, etc. And they're able to attract mates from very large distances using these same chemicals. And so that's pretty much all I have to say about chemicals. I want to talk a little bit more if you guys are still with me. I have got a couple slides. That's chopped off. So if it was smaller, you'd be able to see that it says within nest. I just wanted to bring this up. This particular guy, Brian Johnson. I was working at the Dice Lab, for several years. And Brian Johnson was one of those students that, sort of wandered into the lab, wanted to do a project on bees, didn't know anything about bees, and, after hanging out with him for a couple of weeks, I said to myself, this guy is never going to be a beekeeper. He can't use a hammer, he doesn't know anything about bees, he doesn't know the first thing about bees, and he didn't really get along with the professor either, so he disappeared. He went off to work for Tom Seeley. You've met Tom Seeley, right? You know who Tom Seeley is, right? So he went off to work for Tom Seeley. Next thing you know, he's publishing in all these journals. He had learned the technique that Tom Seeley teaches, which is to use small glass observation hives. They mark the bees with little paint dots, then they videotape, and then they look at these things all winter, study these videotapes, figure out what the hell these bees are doing in there. And he discovered something that no one else knew, which is that bees spend a lot of time just wandering around. And not all the bees. Now, the bees that are nursing, they spend most of their time right in the brood area, do not leave the brood area. So they spend most of their time with their head down in a cell, either nursing or consuming honey or pollen or cleaning that cell. They do all their activities right in the brood area and very rarely leave. Now, the next level of bees he called, and he made this term up, he call them the middle-aged bees. These are not the nurse bees. These are not the housekeeping bees. These are not the foragers, which are the older bees. These are the middle-aged bees. And what they did most of the time was just walk around. They would go and they would look at everything. And all of a sudden it occurs to us, that's probably how the bees know what's going on throughout the hive, is they're actually just wandering around and looking at every single thing. So that all the bees that have that task, they know pretty much what's going on in all parts of the hive. They don't just stay in one area. The next thing that he noticed, which was nobody had noticed before, was that when something happens, like, for example, a comb gets broken, bees don't all swarm over to that area and fix that comb. Because if they did, you would have this huge logjam, and there would be so much congestion, bees wouldn't be able to move, they wouldn't be able to work, they wouldn't be able to get anything done. So what happens is bees scatter themselves throughout the hive, constantly milling around. They'll do this for about an hour, and then they'll just stop wherever they are and start working. So that there's always bees everywhere in the hive, always working, always ready to work, and there's all these bees that are moving around, constantly monitoring. So it seems to be the most logical explanation as to how the work is organized in the hive. There's no boss. There's nobody saying, you got to go over to that corner and fix that broken comb, or we're going to have a mess over there. The bees are all monitoring them together. So basically, nobody's in charge, but all the work's getting done. The next slide. So, like I said, we're going to drop for a moment. For the rest of the evening, we're going to drop the whole chemical thing. This is a mechanical thing. I would have mentioned earlier, one of the ways that wasps, especially small colonies of wasps, one of the ways that they manage the dominance is not through chemicals, but the boss wasp, queen, physically will go over to the other wasps and just shake them. Say, I'm the boss, I'm the boss, I'm the boss. If that queen dies for some reason, then one of those other ones will immediately take her place and start doing that to the other wasps. So they have a dominance hierarchy, which is actually physical. They also have the chemicals, but of course in the honeybee society, there's just too many. The queen can't go around and just shake everybody and say, get yourself in the line. So they use the chemical system inside the hive. But outside, how are you going to get all these bees to motivate? Okay, so it's time to swarm. You got to get half the bees, 20, 30,000 bees. You got to get them motivated to leave the comfort of the hive. Most of them have never even been out before, and you've got to get them all motivated. How are you going to do that? And what Tom Seeley discovered, and actually he was inspired by his mentor, Lindauer, who in the 50s came up with the idea that maybe the bees would have this, what he called a buzz run. They would just run across the comb like that. And this was a way of trying to excite the other bees to some sort of task. And so Tom decided to pick up where Lindauer left off, and using these glass observation hives and videotaping and all this stuff, they discovered that prior to swarming, you would have a lot of these bees going around the combs, just shaking everybody, buzzing like this, and agitating them to the point where pretty soon the whole bunch was all riled up and ready to go on the swarm, and they would come zooming out. You've seen it before. They come pouring out of the front of the hive, and they go off into the air, and there's a cloud the size of Tom likes to say, cloud the size of a school bus. Okay, so now you've got them out of the hive. Now you've got them in a space that's as big as this room. How are you going to get them to where they're supposed to go? And so all in the past, it was always thought it was the odor. But for some reason, that didn't really set well with Tom. He said that can't be it. And it can't be the way that they're oriented. There's too much air, too much wind, and the odor's not that strong. I mean, we can't even smell it. And yet the swarm would, at some point, the swarm would just go like a quarter of a mile or half a mile. They all go together. And the queen is not leading it, because the queen a lot of times is left behind. The queen's in the branch, the swarm takes off. The queen has to catch up with the swarm. So the queen is not leading the swarm. So it's not the odor of the queen, it's It's getting that swarm from point A to point B. What is it? Next slide. So this is what Tom did. The camera. Just, again, with the videotape, they start monitoring the swarm when it's in the air. He's like the guy, the expert of creating swarms. He can create swarms, so that he can have a swarm, when he needs a swarm, where he wants it, he can do it. And so they would film these things, and then they would record the video and study it. They actually use software. You can't quite see it, but this is a screenshot. This is a screenshot of some kind of a tracking software which looks for patterns. And they started seeing these patterns, and they realized that the swarm size of this room, most of the bees are just milling about. There's the top of the swarm, the very top. There's bees that are streaking. They call them streaker bees. It's mentioned there. Streaker bees. Streaker, yeah, up right there. The streaker bees are streaking in the direction that the swarm is supposed to go. And they would see these bees. The bees, as you know, have these eyes on the top of their head. And the streaker bees are going over their heads like this. And this is how they guide the entire swarm to their destination. So this is actually a physical process, has nothing to do with chemicals, and there you have it. So I'd like to just point out this is your swarm, and we've come a long way as to understanding what's going on inside of the swarm. But there's still a lot that's not known. That's why I like to call this the mystery of the hive. There's still a lot that's not known. There's still a lot that people think but maybe can't really prove. I have a theory, though, how we can find this out. Show the next slide. I tried this. Looking from the inside. Didn't work, though. Looks the same on the inside as it does on the outside. So that's it. That's all I have.
Okay. Thanks very much.